Hello, my name is Jeremy Martin. I am the Science and Operations Officer at the Goodland, Kansas office. And I'm going to talk about a wind event we had recently occurring in the community of Burlington, Colorado on September 1st, 2021. You probably look at that date and realize how close it was to our deadline for this conference. Yeah, it actually came in the last week before we had to start getting abstracts in. So this is kind of a first look at it, just an overview of what happened and maybe some insights. I definitely want to look at this case more in the future, but I thought it was interesting enough to at least get it out here to make everyone aware of it somewhat early. Kind of looking at the end first, this is what happened. We had a cell that moved over the Burlington area here as it was decaying. Burlington is right there. The airport is down here for future reference. What resulted here is we had two areas of damage, one here near the airport in the south, and then a more significant area of more widespread damage here around Burlington on the eastern side of the town by the interstate. I did the damage survey. I put this polygon as one kind of continuous area because I didn't really have any data in between those two boxes. There isn't really any damage indicators there. And really the damage indicators were pretty sparse around the airport as well. So it was really hard to determine, was this a couple of microbursts or was this actually one larger macroburst? And unfortunately, this event was unwarned. We did have a significant weather advisory in effect for 55-mile-an-hour winds, but I would say that the magnitude of this event kind of surprised us. So the damage in Burlington, we really had it in two areas. In the Burlington area, we had damage areas north of the interstate. That damage was consistent with 60 to 85-mile-an-hour winds. We did have 76 miles per hour measured right near that previous picture of a shed with the window blown in, the door blown in. South of the interstate was definitely the most intense damage. We had winds consistent with 100 miles per hour near the prison. That's that Quonset you see in the picture here, and we had 4 power poles right next to it that were snapped at the base, all consistent with the higher end winds there. And the second area was at the airport, actually. The Burlington ASOS was knocked out at 212 UTC. And that's kind of what we used for the starting point of this event. At the time it went out, the winds were out of the southwest, I think 220, gusting to 50 miles per hour. But not only did the comms get knocked out, the actual sensors were damaged. The techs told me the wind sensor, the metal posts on it were actually bent a little bit. And the visibility sensor was actually, they said one of the instruments was kind of pointing the wrong way. So it definitely got damaged in this storm. This tree in the picture here was probably the most intense damage I found during the whole event. This was a healthy tree, fairly tall, was snapped. The trunk was snapped and then it was thrown probably 25, 30 feet onto that car, or it rolled into the car. Unfortunately, broke out the back window and did some damage. Interesting enough, and this is kind of a sign in this area, the damage was really sporadic though. The trees north of there weren't damaged. The house thankfully wasn't damaged, although we had a person home when it hit that saw that wall of wind coming, or heard it coming. But this was definitely the most intense, and the damage toolkit type estimates were saying median values of 115. So that's where we got the upper end value for this event, was from this area here. Further north of there, we found another farmhouse area that looked like it had some outbuildings damaged, but we couldn't get to them. The owner wasn't around, and it was well off the main road. We just found some debris like tin and things like that in the field upstream of that area. Again, consistent with the wind directions we were expecting. So thankfully, this more intense area was out in open country, and there was very few things for it to actually damage. For the sake of time here, I can't go do a really deep dive into all the observational data available, but I wanted to give you kind of a broad overview of what the environment was like. We had a 500 millibars at 0Z. This is from SPC's observed analysis. We had a trough approaching the Four Corners area that was lifting out to the northeast. At 850 out ahead of it, we're seeing a low cyclogenesis developing here. Winds aloft to the east of it aren't super strong just yet, 30, 20 knots, but this was forecast to intensify during the next several hours, and also with the help of some decoupling as well, we'd start to see a little more enhanced low-level jet forming, partially due to diurnal reasons, but also due to the approaching trough. At the surface, this is at 0Z, kind of a broad warm sector across your area. A warm front Shows up here pretty well with the isotherms, with the developing low to the west. In that warm sector, we're at 0Z. We were at temperatures in the upper 80s to near 90. Burlington itself had a dew was 89 over 56, which is pretty good for us. Definitely expect some instability with a surface ob like that. It was fairly uniform across that area. There wasn't a lot of wind direction differences or any kind of hidden outflow boundaries or things like that. Just off the surface, 800 millibars, we started to see the first sign of that intensifying local jet. We had 35 to 40 knots here to the south of Burlington, which is KITR. They were right in the nose of this 35 knots. Down here, there's 40 knots. But as you get to 2Z, which is closer to the event occurring, which is about 15 minutes prior to the event, you see that area has enhanced to 45 to 50 knots, with the area of 50 knots getting right up to Burlington there, Burlington proper. So definitely an intensification of the wind fields. You'll see in the next slide with the sounding, this area here is not too far off the surface. It's probably right where the boundary layer was first decoupling. So we had a really strong winds just off the surface coming out of the south. And here's the sounding we have. Now I had to use laps since we don't have any soundings nearby. This is what I was first referring to, where that 50 knot was. Now it's tough to tell because the way the sounding was plotted kind of skews it off. This 50 knots was right around there, right where that inversion first starts. You start to see the decoupling of the atmosphere. So again, less than 1,000 meters off the ground, we were already getting these intense winds just off the surface as these storms were approaching. For instability, our most unstable parcel was about 941 joules a cape, although pretty strongly capped as well. We had downdraft capes of around 920 joules per kilogram, which is pretty good. We definitely get higher values out here, but we'll take it, right? Above zero height was 11,330 feet. Freezing level was 11,833 feet, so not a lot of difference between those two. And our theta E difference, which I like to use for looking for microbursts, was 13C, which is kind of on the low end of the distribution there, but definitely not outside the realm of possibility for microbursts. And now I'm going to do a series of cross sections, mainly before it and until right after the event starts going. You'll see reflectivity, storm relative velocity, and a few of the dew pole moments. Excuse me. I try to take the cross section along the radial so you could get any convergence signatures as well. Again, this is probably 10, 12 minutes before the first event occurs. And decent reflectivity in that 10 to 20,000 feet where the melting level is. We have some 55 to 60 dBz echoes. Extending not all the way to the ground, there's some values down here, but it's definitely not a uniform, solid area of precipitation just yet. Looking at the SRM, you do have kind of a convergence signature here between 8,000 and 15,000 feet. These are the outbounds, these are the inbounds. So you're definitely seeing some convergence, although it's really not, the outbound maximum isn't lined up with the inbound maximum, and the inbound maximum is fairly on the weak side. So 25 knots outbound, maybe 10, maybe 15 knots inbound. So not a really strong signal of convergence, but definitely a convergence signal there. Here's your ZDR and KDP for that time period. ZDR, showing fairly high values, so most of the signal is for rain down here, right? There is this little pocket up here where the values are lower, which correspond pretty close to where the KDP max is, which might be a sign that there's melting hail going on, which would increase the values of KDP to some degree and also bring down the ZDR levels. And it's important to notice that the freezing level is right around here. So this area of enhanced KDP to start is right at the freezing level. Jumping ahead 5 minutes, and this cross section follows along with the storm, so it's not in the same exact place each time. Reflectivities have definitely intensified all the way through the storm, and now we're getting those 60, 65 dBz's getting closer and closer to the surface. I would say the convergence signature has gotten better. Again, the values are still on the weak side. This is probably 25 knots inbound, 5 to 15 knots inbound. Excuse me, I probably misspoke that. But there's definitely a convergent signature here, but it's still pretty broad, and I wouldn't say it's too on the strong side. I'd imagine maybe 20 knots of convergence total there. ZDR, similar to before, we're seeing a nice area of large ZDR values all along where the updraft is, again indicating mostly rain, especially in the low levels. KDP, what's interesting is that we still have that area of higher KDP values right around the freezing level, but we have this area that's already descending down to the ground with these values around 4 approaching the surface. And for CC, because it's important to have that in there, just to give you some proof that there is some melting hail going on, we have this reduced CC right along that same area where the KDP gradient is and the ZDR values are. So definitely some melting hail, but it looks like it's, for the most part, probably all melting before it reaches the ground, which would further enhance any downdrafts. All right, here's a cross section 1 minute prior to the event. Again, using that time where the ASOS went out as your ending time. Again, intense reflectivities at and above the freezing level and all the way down to the surface now with some 65 DVZs extending all the way to the surface. Interesting enough, we see the first strong inbounds, signs of the actual downburst hitting the ground and spreading out down here. ZDR and KDP kind of shows the same thing as the reflectivity. High ZDR values near the ground, kind of showing that precipitation blob reaching the ground. KDP values as well, following down to the ground with that enhanced area of KDP above 4, the yellow, just 1 bin off the ground now. And we've actually at this point lost the KDP max at the freezing level. Now the event's ongoing. This is actually as it's heading towards Burlington. You can see definitely the reflectivity is now more weighted in the lowest half of the cross section, below 10,000 feet. Again, ZDR values are very high in that same area. KDP is definitely, CC is a lot noisier now at this point. Again, indicating there's probably a mix of rain and hail going on. Some of the values are very low. I'm not sure if it's noise in here or just outside the higher reflectivities values is probably more likely. Looking at KDP as well, we have this area of enhanced KDP right here again. It's like a new area, a new downdraft developing, and this is just before it reaches the area of the prison and things like that. So that's why I said earlier it looked like there might have been multiple microbursts instead of one big macroburst. Although I didn't have enough damage data to really say that for sure. This radar loop here is just going to be just kind of show you what was happening at velocity wise. I'll let it loop here as I speak. One thing I noticed is the velocity values never really get all that strong. This is the max half-degree velocity data during this sequence here. And it even starts pretty early at 47 knots, 48 knots, and kind of hovers around there. It does peak at about 219, which is actually after it's gotten through most of Burlington, at 57 knots, and then kind of falls off again. For what it's worth, I don't have the plot here, but the speed of this cell actually stayed the same the entire time as well. But it did bring up a question, you zoom in here, this is at the time the ASOS got knocked out, and the ASOS was at that red dot. If the maximum winds seemed a lot higher based on damage than what the ASOS what the radar could show. And I looked a little bit closer, and it all comes down really to that direction the damage was laid out and the direction of where the strong winds came from. Obviously, you guys all know radial velocity is what our radar measures. It's not the true actual velocity. We actually, based on the last report of the ASOS and some of the damage laid out, wind direction of around 210, 220 was probably realistic of where the winds were coming from. And that gives you this angle theta. You can plug it into the equation to the right. You put the radar value in, divide it by the cosine of that angle, and it gives you an estimate of what the actual velocity was. So you can see if you take that maximum and apply this wind direction to it, it's actually close to 65 knots is what the radar was actually sampling if you account for the radial factor of it. But that's still significantly below what the damage indicated there. And you'll notice as you go farther north, even back into where the actual ASOS was and stuff, the winds drop off a lot. And looking a little bit closer at that, it seems more likely it was, again, a function of the wind direction. As you go further north, the radial angle velocity angle changes and gets greater and greater to the point where we're approaching 75 degrees or more difference between the actual true surface wind and what the radar was estimating here. So I wanted to look a little closer in what impact the viewing angle actually had here with this event. The area right in here is the prison area is right in this area right here, right? So I was curious. All the damage there was laid out to the north and even some degree to the northwest. And the radar viewing angle was about 260. So I assumed, the wind directions, the smallest one I could get that would have the smallest difference between the observed and the radar viewing angle was about 185. And that gave you an angle difference of about 75. But if you plugged in that value up there of 20 knots, divided by the cosine of 75, it actually gave you about 90 miles per hour per estimate. Now, granted, that angle is getting really big, and there are all sorts of other assumptions go into this estimate. Is that angle is getting so big where maybe the estimate's not quite reliable. But it does give you some indication that maybe the reason the winds weren't so observable as being as strong, besides not being right at the surface of the radar, but also the viewing angle was one where it actually kind of masked how strong the winds were. So in summary here, we had an intense macroburst or series of microbursts impact the community of Burlington, with winds up to 115 miles per hour, based on the best available data I had on damage. Fortunately, the event occurred without a severe thunderstorm warning in effect. The environment was somewhat supportive of strong downdrafts, further enhanced by that intensifying low-level jet I mentioned. KDP values were supportive of enhanced downdraft, with maxima first appearing around the freezing level and then descending. But also the radar viewing angle probably played a role in why the magnitude of the event wasn't really sampled well by the radar. I do have some future plans. Since this is just an initial review, I really want to compare this event to some of the recent research on KDP and microbursts. And also I want to contrast this storm with the other storms during the time period, because it's easy to point this out and go, yeah, something happened here and here's some obvious signs. But it's less helpful if we have 5 other cells that look just like it that didn't create a microburst here. So that's definitely something we're going to look into and more. And I guess I'll open the floor now to any questions if we have time available. Thank you.